All right, welcome back. So this is going to be our next lesson for the AWS Machine Learning Engineer Associate exam. So what is it we're going to cover today? Well, before we get started covering it, you need to like, subscribe, and share this with anyone else you know who might be taking the AWS Machine Learning Associate. Why? Because this is going to be critical during this time when everything is moving towards AI. So what is today's lesson going to be on? Well, we already covered that in the general stuff we're going to go into, but today we're going to focus on data ingestion and storage. Let's begin. So machine learning workflows begin with data, and understanding how data is collected, stored, and managed is foundational for any machine learning engineer. In AWS, managing data effectively means dealing with different data types, storage solutions, data movement strategies, and orchestration tools. In this section, we'll explore the core concepts behind data ingestion and storage, provide detailed insights into the AWS services used for the tasks, and offer console-based walkthroughs for hands-on learning. We'll probably do one walkthrough because this is going to be a pretty simple setup. Okay. So, what are the basic data types? All right. You have three at the heart of this. Let me go into. All right. One, at the heart of data management lies the understanding of structured, semi-structured, and unstructured data. First, we'll go into structured data. You should bookmark this, and you can see the link here. I'm not going to type this into the screen. You should be able to read this, or just type up structured data, AWS. Structured data is organized into defined columns and rows, such as a relational database, the tables in those, a CSV file or Excel sheet, right? So this data is predictable, consistent, and easily queried using SQL. All right. Unstructured data. What is this? Unstructured data lacks a defined schema. So an example might be images, videos, audio, raw text documents, emails. These are a lot more unstructured. So querying unstructured data requires pre-processing to extract metadata or transform the content into something that can be processed, parsed, and queried. All right. So mark that and do a little search for AWS unstructured data. You'll get this information. You'll be able to go through this. All right. And then finally, we'll have semi-structured data. So this is a gray area. This has internal tags and structures. Think like a JSON or an XML or a log file, but it's not as rigidly organized as a structured data. Think of an Excel sheet, right? So parsing logic is often necessary to make this data usable. These distinctions are crucial because they determine how data is ingested, processed, and stored. And data is at the core of any of your machine learning pursuits. All right. And then again, what do we have to pursue outside of this? All right. What you're looking for are the three V's of data properties, right? One, volume. This refers to the amount of data being processed, which significantly impacts storage and processing decisions. For AI applications, data volume can range from gigabytes for small projects to petabytes for large-scale machine learning initiatives, right? High volume scenarios like social media platforms generating terabytes daily or retailers maintaining years of transaction history require distributed processing systems rather than a traditional single server solution. Then you have velocity, number two. This describes the speed at which data is generated, collected, and processed. This property determines whether batch processing or real-time streaming is appropriate. High velocity scenarios include Internet of Things sensor data streaming continuously, or high frequency trading systems where milliseconds matter. For AI applications, velocity affects model training frequency and real-time inference capabilities. And then three, variety. This encompasses different types, sources, and formats of data being processed. So modern AI systems often need to combine structured database records, unstructured text documents, and semi-structured JSON logs. So this variety influences storage architecture decisions and may require multiple specialized data stores with unified querying capabilities. Okay. And then you have different types of data storage. All right. Let me see if I can find a nice image of this. Warehouses versus data lake houses versus data lakes. All right, let me see if we can find a nice image to show you what that would be. All right. Let me see. Let's see. This might work. And then we'll do this because AWS pretty much goes data warehouses and data lakes. All right, so this should work for you. That's not a good image. All right, so this will show you here. All right, so there's three different types within AWS, right? You have your data warehouse. What is the schema? The schema is on right for a data warehouse. It's more structured, it's more rigid, and it's commonly used for something like business intelligence, reporting, or analytics. Then you have a data lake. This would be an example, would be S3 for storage buckets, right? This would be a schema on the read. The data format would be a lot more raw. The flexibility would be high, and it would be good for machine learning, discovery, or archiving. And then you have a lake house. This would be an S3 and Redshift. So the schema would be both read and write, and then the format would be somewhat flexible, but with some structure within it. But the flexibility would be pretty moderate, and it would be a good for a unified analytics and machine learning pipeline. All right. So there's a lot of different ways you can think about it. But if you can look at this, you'll get a good idea of how to visualize and how you'll make your selections. Okay. And you can see this one gives you a little bit more. So remember, a lot of this is you have to get the concepts down. You have to understand how to use this in the cloud, and then you'll be able to make better choices. All right. Let's see. Let's open this in a new tab so we can see if get this nice and large. All right. Hopefully that makes a lot more sense to give you a good visualization here. Okay. All right. So let's go a little bit more into data warehouses. All right. So data warehouse represents the legacy approach to data engineering. This functions as a centralized repository optimized for analysis. This will store data in structured formats using extract, transform, and load processes, ETL, where data will be cleaned, organized, and then stored. The architecture typically employs star or snowflake schemas optimized for read-heavy operations and complex analytical queries. Amazon Redshift serves as AWS's primary data warehouse offering. It'll replace expensive traditional solutions like Oracle databases. So data warehouses excel when working with structured data sources, requiring fast, complex queries, and needing integrated business intelligence capabilities, like think of a Power BI endpoint. They use schema on write methodology, meaning the data structure must be defined before storage. All right. Then you have the data lakes. Data lakes store vast amounts of raw data in native formats, including supporting structured, semi-structured, and unstructured data without predefined schemas. This approach uses ETL and it stores raw data first and applies transformations later as needed. So S3 serves as the foundation for AWS data lakes, with AWS Glue providing schema discovery and Athena enabling querying capabilities. So data lakes offer superior agility compared to warehouses because they don't require upfront schema definition. This flexibility makes them ideal for machine learning applications where data requirements may evolve. They support batch, real-time, and stream processing while enabling data exploration and transformation for various use cases. And then data lake houses. This is the hybrid solution. So data lake houses combine the best features of both architectures. This provides warehouse-like performance and reliability while maintaining lake-like flexibility and cost efficiency. So AWS Lake Formation combined with S3 and Redshift Spectrum kind of exemplifies this approach by allowing structured querying of unstructured data stored in S3. So this hybrid model supports both detailed analytics and machine learning tasks while enabling the ACID transactions through technologies like Delta Lake. And I never remember ACID on the S SQL. So let's get you a good definition here. Atomicity, ensuring that transactions are treated as a single indivisible unit of work. Consistency ensures that transactions bring the database from one valid state to another. Isolation ensures that the concurrent transactions do not interfere with each other. And then durability, that once a transaction has been successfully committed, its changes are permanently stored and will persist. Okay? So simply put, data warehouses like Redshift are ideal for structured data and complex queries. They use ETL pipelines to transform data before loading. Data lakes like S3 store raw data of all types. Tools like Glue can catalog and process this data on demand, right? So this is that ELT strategy. And then lake houses, all right? Lakehouses combine the flexibility and performance. And AWS this often involves S3 as the data lake and Redshift Spectrum for querying like a warehouse. All right. And you can see some of this. Oops. Here. Okay, so let's go and show you how we can do this. All right. Let's go to S3. I'm going to create a quick bucket. Okay. AI sample bucket. All right. We don't need the copy settings. ACL's disabled, so there's no access to it. All public access is blocked. We don't need versioning. We don't need tags right now. Bucket key, we'll keep it enabled. Server-side encryption, yeah, we'll keep that enabled. That's always good practice. Click create the bucket. Oh, sample bucket, Azure DevOps. We'll just do that. So it gave that because somewhere in the world, there's another bucket with that name. That's okay. All right. So we're going to try and upload some sample data to that. Do I have a CSV available? Give me a moment. We go into this bucket. All right. Drag and drop. Trying to drag and drop. Did I do? Oh, I did. Okay. All right. We dragged and dropped. All right. And then let's go to Glue. All right. Let's see. Through databases and catalogs go to the data catalog. Add tables using crawler. We're going to the crawler. Yeah. Sure. DevOps crawler. Next, choose data source. Data source. S3. Network connection. Oh, ooh. Added. Wait. S3, right? Let's refresh. Oh, here's a button. Okay. Choose this bucket. And this account, okay, this one is not on another account. I didn't read that close enough. All right, crawl all subfolders. Well, that's a good default. Or you could do new, or you could do based on events that are event driven. Okay, we're going to add that S3 source. Go next, choose an IAM role, SageMaker. SageMaker catalog products. Yeah. Okay. Make formation. Choose a database. You can choose one or you can create one. So let's refresh. Add database. Table prefixes. All right, let's try this. Default. And so, okay, right here, you can review, you can create. All right. Now, I'm not going to create this just because it's going to start incurring charges. And you saw at the front, I'm in single digits for this month, which I like. All right. So over here, we would go to Athena, right? And we would launch the query editor, and it does cost. And then you would point Athena to the data source, all right? And then from here, you could start querying with your SQL queries, all right? And those SQL queries would be, the same things we would do. Select from my table, limit 10, semicolon. Oops, that should be select, right? So this would be something that you could run the query on. And then this would demonstrate a schema on red, right? This is a cornerstone of data lakes. All right. So we're going to close this out. All right. We're going to cancel this. We're going to cancel that. Okay. So ETL versus ELT pipeline. So let's explain some of that. All right. Let's see if we have something on that. Do I have a... Okay. Save this. All right. What's the difference? You can save this on here. All right. So within this, there's three phases. E, extract or extraction, right? This involves retrieving raw data from various sources, including external databases, CRM systems like Salesforce, or flat files, APIs, or data repositories, right? This extraction process must ensure data integrity while handling potential failures through retry mechanisms and appropriate error handling. So the velocity of data determines whether extraction happens in real time, near real time, or batch fashion, right? Then you have the T, transformation, all right? So this converts extracted raw data into formats suitable for the target repository. So this includes data cleansing to fix errors and remove duplicates, or enrichment by combining multiple sources, right? You can format changes like convert date strings to date time objects, and then you can aggregate and compute for summary statistics, right? You can also encode or decode for different formats, and you can handle missing data through imputations or rejection strategies, right? So you're basically cleaning up the data. And then finally, load. All right. So loading is moving the transform data into the target system, like we did from that S3 to Glue. That would be loading. Well, it actually be loading into it since it was already structured data. We use a CSV document, but I'm just giving you a framework, right? So you would put that in the target system with the appropriate integrity checks, failure handling, all that. Right? Loading can occur in batches for large data sets or streaming for real-time requirements. For machine learning applications, loading often involves preparing data in formats optimized for model training, like feature stores or training data sets. So the ETL, extract, transform, load, and in ELT, extract, load, transform patterns define how data is prepared, right? So ETL would be used in data warehouses where data is transformed before being stored. And then ELT would be used in data lakes. So data is stored raw and transformed later when needed. So the basic steps again, extract. You pull the data from the sources like the APIs, the databases, or the logs. Transform. This is where you can clean, you can enrich, you can normalize data, right? This could be encoding, imputation, changing dating, formats, all that. And then load. This is where you move the data into the target. That could be Redshift, that could be RDS, relational database system. And you be ready to move it with your model. All right. So then there's orchestration within AWS. All right. Let's see if this is it. Okay. So orchestration. Let's see. Do I have this? Where is it? Okay, there we go. Okay, so orchestration. AWS has several services for automating and orchestrating data pipelines. So Glue provides the automated ETL, ELT capabilities with event-driven processing. And higher-level orchestration services include Amazon's EventBridge for event management, Amazon Managed Workflows for Apache Airflow for complex workflow management, and AWS Step Functions for serverless orchestration, and Lambda functions for lightweight processing tasks. So managing these processes requires orchestration tools we went over. Glue for automated ETL pipelines, Step Functions for managing multi-step processing logic, EventBridge for triggering workflows based on events, like a file upload, and then Managed Workflows for Apache. So this is a popular open source orchestration that works with it. And it's good for multi steps, okay? And then let's store this. Save that for Glue, save that for Step Functions, and you can go in there and see it a little bit more. Save that for EventBridge, and then save this for Apache Workflow or Airflow, all right? So the data mesh. So there's a data mesh paradigm. So data mesh represents a paradigm shift towards decentralized data management, where individual teams own their data domains while following central governance standards. This approach treats data as products offered by domain experts to other organizational units. AWS provides excellent data infrastructure for data mesh implementations through services like Lake Formation and for governance, Glue for cataloging, and in various storage options supporting domain-specific needs. So you saw all these tools we were talking about moving around. They can use their own things under the overall governance of AWS and the well-architected framework, right? So within this, teams can own their data domains and publish data products. That's one. Two, there's centralized tools like Glue Catalog, Lake Formation that govern access and discovery. And then three, there's federated governance that ensures security and compliance. And then AWS will support that data mesh with Lake Formation, Glue Catalog, to control the access at the table and column level, and then share the metadata repository for cross-team discoverability. So this structure scales well in large organizations where multiple departments collaborate on machine learning projects. So here's some final thoughts. If you're collecting clickstream data, ingesting sensor streams, or blending structured logs with unstructured documents, AWS's tools will build scalable and secure data pipelines. The key to mastering ingestion and storage lies in knowing when to use a data warehouse, a lake, a hybrid lakehouse, and how to automate the ETL or ELT flow efficiently. So first you start with S3, start with Glue, explore Redshift and Athena for querying, and understand the orchestration tools that automate the flows. The better your foundation, the more effective your machine learning models will be. That's the end for this lesson. I wanted to say thank you for joining. Hit the like button, subscribe, and share this with anyone you know who might be taking the AWS Machine Learning Associate exam. I'll see you in the next one. Have a good day.